Okay, well, today I'm going to talk a little bit about some collaborative projects with industry that have been undertaken by students at Brunel University, London. So my name's Richard Bonser and I'm a reader in biomimetic and design. And for about the last 15 years I've been fascinated by design inspired by nature. We think that it has a great role in sustainability because in general biology doesn't waste much energy or resource, so if we can borrow the principles of biological design, we hope we can make technology more sustainable. So we're passionate about working with business at Brunel, and many of our undergraduate research projects are collaborative with industry. So roughly 40% of our final year projects have an industrial collaborator. And we think that this works really well because on the one hand it means business can get a bit of research done by a bright young student, and also the student gains from being able to work on a live project related to a real problem. Now, our work in this area is facilitated by the Co-Innovate project, which I'm sure Rob will tell us a bit more about later on, which really aims to put business SMEs in the London area in contact with the design research base. And the aim of this project is to assist SMEs to become more innovative. So, getting on to projects. This project is related to renewable energy, and the project sponsor here is a company called Solar Botanic, and CEO Harry Corrigan is being really passionate about trying to develop a novel way of harvesting both wind and solar energy in a not very environmentally damaging or invasive way. So moving away from ideas of wind turbines or roofs covered with PV, he has been working with us to try and develop a tree-like solar and wind energy collector. And here you can see a prototype mock-up. This is just a small-scale 3D print to give you an idea. And we've had 3 students working on this. This model was created by Elise Hounslow, who a couple of years ago did her final year project developing dye-sensitized solar cells that were a tessellated design that looked quite leaf-like. Gerard Jansen is currently a fully funded PhD student working in mechanical engineering, and he's looking at ways of using hydrogen fuel cells to store energy. And at the moment, my student Harvey Rutland, a design student, is looking at ways in which he can harvest mechanical energy from the sway in the branches when they're subjected to wind flows. So the aim is really to produce this combined solar and wind energy collector that will look quite nice and blend in with the environment. We're also thinking it may have industrial applications as well as domestic ones, simply where you want to power something that's off-grid. And also we've been looking at the potential of this with an ideal that it will power a 3-bedroom house. So the idea is you have one of these in your garden and you don't need grid power sources. The next 3 projects are all sponsored by a small architecture practice based near Waterloo called A Studio. And we've been working with them for a number of years. This was one of the first projects we did, and this was a project to build an algal bioreactor that could fit in a building facade. So Ray Wilkes, the student here, became a bit of an algal scientist in a way because he was looking at whether you could grow algae at ambient temperatures in the UK, and then his design background kicked in where he came up with a standard facade panel that contained a heating element and the ability to pump air through to help the algae grow. So this was a good proof of concept. The idea was that you could cover your facade of your building with these panels. It would reduce the amount of solar gain into the building, and you would be producing biomass that could either be used for fuel or perhaps the production of nutraceuticals, things like this. Next, and you can see this project on the other side of the Brunel hut over there. This was the idea of a living facade, and the student involved here was Izzy Scott. And initially she was tasked with producing a lightweight facade panel that could be bioactive, i.e. plants could grow on it. But the initial brief included the criterion that it had to be made from crushed Portland stone waste. Well, Izzy started working on this and rapidly found out that crushed Portland stone waste, when rain falls on it, becomes incredibly alkaline, so it wasn't really conducive for plant growth. So instead, she used a lightweight clay spherical hollow aggregate instead, and produced a material that absorbed enough water to keep the moss hydrated, and it also means that this, unlike other living walls, doesn't require a source of water. And in fact, mosses are really hardy organisms. Izzy had some samples that had gone completely brown and dried out. She sprayed them with a mist of water, and the following day the moss was nice bright green again. So really quite a resilient system. So the idea here is that you're bringing a bit of nature into cities. You're obviously absorbing carbon as the plants grow, and you've got a lightweight material to help you do it. Also, it gives a really neat aesthetic. Then finally, this is Alex's project, and he was looking at growing structures. Again, there's a bigger poster on this on the other side of the Brunel hut, and he was trying to grow fungal hyphae with growth medium of cardboard or wood shavings, and trying to make large three-dimensional structures. He ended up using like a tubular cotton bandage to grow them in, so he had structures that were designed like that with tubes. So again, you're growing something without the need of energy, and his project was demonstrating that you can grow structures of quite a large size. So, how would I say that this is economically and sustainably beneficial? Well, the first thing I think is everybody is a winner. These projects enable companies to perhaps try out a bit of research in an area that they mightn't necessarily have time to do. Also, it improves the research capacity of the company by getting these bright students in to help. The other thing for students is that it's really great for them as well. It really enriches their educational experience. All of our collaborators come in and see the students. They have lots of contact with them. They get them into the companies to see how the companies work. So it's a really neat way of making our students or our graduates more employable and be able to hit the ground running when they get into companies. And finally, it builds long-term relationships. You know, we see industry helping our educational provision as being key, but then if we've been friends for a few years, you might start getting us to do some research or other activities for you, or likewise, we could perhaps bring you in to enrich our student experience. So that's the end of my presentation. Thank you for your attention.